We are looking at how to calculate for the value of an unknown resistor in a given circuit. And on the board, we have a parallel network. We have R1 with 5 ohms. We have Rx to be unknown. And we have R to 20 ohms. We have the supply current. We also have the current flowing across the board, the 5 ohm resistor. So from Ohm's law, V is equal to IR. And we also know that in a parallel network, the voltages across is the same, while the current varies. So on that basis, we can use Ohm's law to calculate the voltage across the R1 resistor because we know the current flowing through the value of the R1 and that value is 5 ohms. So from Ohm's law, V is equal to what? IR. So the voltage across R1, so say V1 is equal to I1 across R1. So V1 is equal to the current is 8 amps. So 8 times 5. This will give us 40 volts. So the current across the voltage across this is what? Is what? 40 volts. Now we want to calculate for the current across these 20 ohm resistor because you know the voltage now. The voltage across is what? Is 40 amps, the 40 volts. So V is still equal to IR. So V across R3 is equal to IR3 times what? R3. So you make IR3 the subject of the formula. So V R3 over what? R3. So this is the formula to calculate for the current across the 3 ohm, the 20 ohm resistor. So let's move to this side. So now IR3 is equal to the voltage is 40 volts. So 40 over 20. 20. So the I plus R3 is equal to what? 2 amps. This is the current across what? Resistor 20 ohm. Now we know the voltage across the whole resistor, but we have to go for the value of Rx. Now to calculate the value of Rx, we know V is still equal to IR. So to look for this value, so it will be V across Rx. This is Rx. This is what? Rx. Now I know the voltage. I don't know the current, I don't know the resistance. So I can't use V equal to IR. I have to calculate for the current across the Rx resistor before I can get the value of that resistor. Now, I know the supply current. Here, I know I have 2 amps here. I have 8 amps here. So to get the current here, I will use Kirchhoff's current law, which says the current entering a node is equal to the current leaving that node. So the I supply, IS is equal to what? The current here and the current. So this is I1 plus what? I3. So 11 is equal to 8 plus 2. So 11 is equal to 10. So 10 plus, now this place is what? The current across IRX. IRX. Now plus IRX. So you do the subtraction. So you have 11 minus 10 equal to what? IRX. Now this will give us 1 is equal to IRX. So the current across resistor RX is equal to 1 amps. Now we have the current across the resistor. We can now look for the value of that resistor. So we go to the second side. We know how V is equal to IR. We know the voltage. So V across RX. This is RX. This is RX. We know the voltage. The voltage is 40 volts. From this point we calculated. Because the voltage across is the same. So the voltage here, 40 volts. So now we come back. IRX is 1 amp. We found it here. So times 1 times RX. So when you multiply, you have 40 is equal to what? 1 RX. Divide both sides by 1. So RX is equal to 40 ohms. So this will be the value of the unknown resistor. See you in the next class.